So I'll be going through a lot of concepts. So if you have any question, you just raise your hand. Okay, but we're gonna have probably some few minutes in the end so that you can also raise your questions. And at the end, I'll try to explain some of the code that we can write for using chain streams. Okay. Cool. Where's the? I'm sorry. Okay, so who am I? I work, as I said before, at Managed Services. I began working at Percona in November 2020 as a MongoDB DBA. Back in 2016, I started working with IBM DB2 on mainframe and Linux, and eventually I met open source databases, right? And on Managed Services, our main goal is to manage, monitor, and troubleshoot the database environments and support our clients with their questions they may have about their system. We work on database migrations and many other challenges your environment may face. So if you run into trouble, just talk to us. We're available 24/7 all days of the year. So yeah. I mean, we're supporting MySQL, Postgres, and MongoDB. So, okay, of course, we're hiring. So if you're interested, just take a look. So a little bit more about what I do. So as I said, I'm a MongoDB DBA, and our day-to-day job is a little bit different than what SQL DBA usually does. So MongoDB is a distributed system by design. So whenever us as DBAs, we have to make choices, we have to take into account the inner workings of the replica set and of sharding, right? But a problem that happens in almost every database is that, well, your data can get big real quick, okay? Over the last year, we experienced massive data growth in one of our environments. And before talking about chain streams, I'm going to explain what problem we try to solve with them, okay? So think of an environment like this, right? We, instead of having just 2 shards, we had 8 shards, okay? And in each of the shards, we had, instead of 3 members, we had 4 members. So if you do the math, we're gonna have 32 data-bearing nodes, okay? And that's just the data-bearing nodes because we also have the routers, right? We had 1 router for each shard, so 8 routers. And what the routers do is that they receive the requests from the application, and they check out which of the shards has the data that you need. And they get this data from the config server. So that's the main architecture, right? Let's see. So as I said, 8 shards, 4 replica set members. And what happened is that we had to attach around 4 terabyte SSD disks on each member. And they were already 70% filled, so we kind of had to act fast because data was growing, right? So, okay, that translated to 128 terabyte disk in storage costs. And also, each of the MongoS processes were receiving around 5,000 operations, sometimes less, but usually 5,000 operations. Most of the operations, we had like 50% of the operations that were read requests, but we also had this behavior from the platform where we had 1 insert followed by several updates on the same document. Okay, so yeah, 50-50, it's, for me, it's considered a write-heavy application, right? Okay, so the simplest solution that we could come up with would be to delete the old data that we had in batches, right? Of course, that alone would not work because when you delete a document in MongoDB, you don't actually release any bytes to the operating system, right? So MongoDB works very similar to other databases with deletes in the sense that instead of actually doing work on the record, like raising something, there's usually a metadata byte that gets touched, saying for future transactions that this record's no longer visible, right? So what did we have to do to solve this problem after deleting all this old documents? So there's a command in MongoDB called compact, and they work on wired tiger files. And the idea is to eliminate all these bytes that are not being used anymore and make your whole collection smaller, right? The thing is that their effectiveness may vary. So I'm going to quote what MongoDB documentation says, right? They say that the effectiveness of this operation is workload dependent and no disk space may be recovered. They don't actually explain why this happened, though, but they do explain is that the command is useful if you have removed a large amount of data from the collection and you do not have any plan to replace it. That would be our case if we decided to delete our old data in batches. But we suspected that compaction alone wouldn't solve our problems. So at the same time, the performance of the cluster was already poor, right? If we started these batch deletions on our cluster, there was a high chance that we're going to fill this additional workload and the application would fill it as well, right? So we had around 7 billion documents that had to be deleted. And we had to estimate how much time it would take to delete all of these records in a way that the cluster wouldn't be impacted. So we would start one batch deletion and then wait a little bit, wait for MongoDB to do its stuff internally, and then we would start another batch deletion after some minute or so, right? So we had to come up with an alternate solution that wouldn't impact performance so much, and it would be also faster because the batch deletions would take a long time to complete, right? So how could chain streams help us, okay? So before talking about chain streams, we have to talk about the aggregation framework, okay? So we have to talk about the aggregation framework because that's what the chain streams use internally, okay? So books define the aggregation framework as a set of analytics tools that let you generate advanced reports that you can already do in SQL, for instance, but this time we're using MongoDB's own aggregate method instead of course, a regular group by, right? So we have just a simple example, right? So let's say that you want to know how much money was raised in a, I don't know, charity campaign that your company promoted last month, okay? So, and you would group this, the amount of money by state, right? We would write something like this, and what would happen is that in a SQL database, the optimizer would figure out what are the best steps to get you the right data, okay? So that's what we have in MongoDB, right? So if you check the pipeline constant, you're gonna see that we have an array that defines the steps that we need to run sequentially, right? So we put this array, and then what we happen is that we call this aggregate method, sending the pipeline as a variable, okay? Okay. So another thing, usually a good practice that we have is that we need to put the match operator first, because this way you're gonna, and also on an index field, because this way you're gonna have a faster result. But we're gonna talk about sharding and how it works, so I'll get to that later, okay? So, okay, just some overview. So as you probably already know, the aggregation framework works as like a pipeline, right? We have an input, we have many stages that do some sort of modification with the documents. And what happens is that the input of the output of stage number 1 will be the input of stage number 2, and so on until all of the operators in that array that I showed, all documents go through each of them, and you have your final output, and that's what's your application will want. So that's what we call like a stream of documents, okay? So it looks very similarly in shell, right? You probably use that a lot, okay? But instead of course, having like a text output, you're gonna have documents to work with from your MongoDB drivers. So you can repeat stages in your pipeline whenever you want, and that's fine. Okay, so when we use the aggregation framework on a sharded collection, what happens is that MongoDB is going to split your pipeline in two. So what happens is that when you have like a group operator, all the stages before that are going to be sent to each of the shards, okay? And each of the shards will get the data that you need from the match operator, okay? And then these results are going to go to the MongoS process. And this one's going to merge the results, okay, and they're going to send back to your application, right? So, okay, the aggregation framework exists since 2013, so it's fair to say that MongoDB designed the database with that in mind since its beginning. But what happened since 2013, right? Okay, I'm pretty much sure that you've noticed that the traditional request-driven model is losing a lot of space to the what we call event-driven architecture. You don't have to check your Gmail inbox to see that you received a new message. You don't have to access LinkedIn to know that someone is waiting for your reply. I mean, they'll let you know, okay? So these solutions rely on the so-called event-driven architecture, which broadly take the following forms, okay? So we have the pub-sub model, okay? That's what Kafka and other solutions use, okay? So you have publishers, okay, that will write into one, in an event stream, a hub, right? And you'll then have subscribers which will listen to the events that are coming in. The subscribers can filter the documents that they want based on topics, okay? So in this situation, you have the fire and forget pattern that the publisher does not care if the subscriber is being able to read the documents, okay? They just send the documents to this hub, and eventually the subscriber will read this event, and when all subscribers have read the events that they want, the event's gonna disappear, okay? With the event streaming model, instead of having a fire and forget pattern, we have the message relay. So what happens is that with this tight coupling, which means that the subscriber is listening to event log as it is generated directly, so the consumers can stop the event consumption and resume it whenever they want, okay, from any point of the stream, okay. And in this solution, the event log should be durable. That's something that you need to take in account as well. And you can have concurrent consumers from this event log. Okay, that's one of the requirements for a good event streaming solution. Okay. So yeah, there are many open source solutions that kind of do that. Okay. So we have Kafka, we have Redis, we have Kafka streams, but we're going to explain the chain streams and how they work in this examples. I mean, where they stay at, right? Okay, so if we're talking about streaming events, we have to define what an event is for MongoDB, right? So when CRUD operation happens on MongoDB, it can be a document being inserted, modified, or even deleted. MongoDB tracks these changes by placing them first on a fixed size collection called oplog.rs. So this collection can be found at local database under the name of oplog.rs. So in fact, the MongoDB replication protocols relies on this collection to work. Okay, since every secondary node that we have in the replica set reads this collection and replaces the changes on its local oplog.rs collection. So this makes the state of the whole cluster the same because they constantly read the events that are being generated. So, okay, I'm going to explain a few of the fields. Okay. So we have TS, which is the timestamp of when the operation was generated. We have age, which it's used by the global logical clock. I'm going to talk about this later. Okay, but the idea is when you have a sharded cluster, it may happen that you have one operation happening at exactly the same time. So you kind of have to know, you have to order these changes, right? So this hybrid counter gets increased whenever a new operation happens. So this way we can keep track of the order of the changes in the cluster, okay? Then we have op. Okay, which, where is it? Okay, that tells us what kind of operation this is. If it's an insert, an update, a delete, or even many times it's going to be an N, which is a no op, basically an operation generated internally by MongoDB. Okay, well, that's a oplog entry. That's what an entry from the oplog.rs looks like. Okay. All right, so before ChainStream started, there was already a way to implement a very simple event streaming solution for MongoDB using this oplog collection. The idea was to use a tailbow cursor. So, okay, a tailbow cursor is a cursor that does not end, does not stop, does not get closed when it stops receiving documents, okay? So the tailbow cursor looks a lot like the tail with the F option that keeps listening to the events as they're generated. Okay, so what happens is that this cursor is going to keep waiting forever until no new operations arrive, and every 1 second this cursor will issue a get more operation, which will try to receive new documents. If no documents come, it's going to return nothing, and after 1 second, it's going to try again, and it keeps trying over and over again. Okay, so tailbow cursors not use indexes, and they return documents in natural order. Okay, so because tailbow cursors do not use indexes, the initial scan for your query that you're using may be expensive. But after you exhaust the cursor from reading it from top to bottom, the next requests are going to be more efficient. So you just have to basically wait a little. Okay. Okay. So what happens is that sometimes they can get closed if, for instance, the initial query returns no match. Okay. And if what happens is that on this tailbow cursor, you're holding inside in the tailbow cursor, you have kind of a pointer to the last document that was processed. If this document that you're pointing to gets deleted, your tailbow cursor is gonna get closed as well. Okay. All right. So I just said that. I just said that it's expensive. Okay, that's a Python example. It's expensive for the ChainStream to do the initial query, but since MongoDB, I think it was 4.2 version, when we query on the TS field, as we see here, MongoDB has made some optimization that even though there's been an oplog collection and being indexed, not being indexed, it's gonna look like it was indexed. Okay, so only this field can be searched on the oplog collection efficiently. Okay. Do you have any questions on the code? Good. All right. Okay. Great. So, okay, this solution that we just mentioned works great with the replica sets. In fact, I don't know if you've heard about it, but we have a framework, a JavaScript framework called Meteor.js that was launched with this idea in hand. So they use tailable cursors to send live messages to their clients, okay? So, okay. What happens is that when you're on a sharded environment, you have to consider, oh my God, 23 minutes, okay. Okay, you have to make a few considerations, right? First of all, you have the shard migrations. So whenever a shard migrates a chunk file from one shard to another, what happens is that internally you're going to have a lot of entries in the oplog.rs collection, okay? These are not generated by the application. These are generated by MongoDB. So we have to filter them, okay? All right. So, okay. The first thing that we have to remember when we're using aggregation framework, the tailable cursor on a sharded environment, is that we need to handle failovers, right? Even on a replica set. So what happens is that when you open a when you start tailing from the oplog and you have an election, eventually your connection is gonna be closed, okay? And your connection, your driver will reconnect to the new primary, okay? But until that happens, there may be a possibility that many events that were not committed at all, they're going to show up on your tailable cursor. So there are a few ways that we could handle this. We could first send, if this happens, we would stop our application, right? We would check our event log buffer, and we would check what events were not committed in all nodes. We would remove these events from our event log, and then we would restart our application. Another thing that we can do is that instead of listening only to the primary oplog, we can listen to all of the oplogs in all of the replica set. And we can only filter the documents that are majority committed or that were replicated in at least one of two of the majority members of your replica set, okay? Okay. So we also have to talk about orphaned documents. Okay.
Why would it be like an event in a blog that hasn't committed yet? So how is it possible? Just my understanding is like if it's written in a primary node, it gets to all blog, and it has been committed, right? How come it gets secondary stuff?
Yeah, the thing is, you first generate this event on the primary, right? And eventually these events are going to show up on the other oplog collections, right? If before that happens, there's a failover, you're not going to have the same documents on the oplog collection on the other secondary nodes. Yeah. So you would have to check all of the oplogs, merge all of the oplog entries, and see if you have, like in a 3-member replica set, if at least in 2 members, for instance, there is the same event. Okay, so if that happens, you know that eventually your document is going to be somewhere else. But if you only have this event in the former primary node, it's not going to be on the other nodes, right? It's going to be rolled back. So you have to take that in account.
It's already in the oplog.
In the former primary's oplog. but it hasn't been replicated. So in the failover, these records are going to be discarded. Okay, so if these are discarded, you should discard them on your application as well. Okay, right.
Arlindo, sorry. So you have a failover, then you compare the uploads.
Yeah.
You can find differences. You said that you check for every similar document. Wouldn't that take a while? Would it not be easier or better to check the documents that aren't in one, like a differential check rather than?
Well, you would have to come up with your own code implementation using concurrency. There are many ways to solve this. So it can take a long time if you don't, take some time developing it. Okay, so you could just merge them at the same time, and you would use the oplog internal fields to check if the event was replicated. So it's complicated. It's not easy. Okay, so that's why chain streams were created in the first place. Okay, I'm just explaining a big problem here. Yeah, no, makes sense. Okay, so orphaned documents. What are orphaned documents? So when a shard gets migrated from one shard to another, okay, not a shard, sorry, a chunk gets migrated. Usually, you're gonna have delete operations on the chunk you're removing the chunk from, the shard you're removing the chunk from, and then you're gonna have insert operations on the other shard, right? That doesn't always work. Sometimes what happens is that your delete operations may fail because of some weird issue with MongoDB. And in this case, what you're gonna have orphaned documents. These are documents that don't actually belong to anyone. They just sit there and no one cares about them. Your application is never gonna see these changes, okay? But what happens internally is that whenever you're updating many documents at the same time, it may happen that one of the orphaned documents get actually updated. Even though not belonging to anyone, the request from the application is gonna internally update this document that doesn't belong to any shard, and this document is gonna show up in your aggregation, your tailable cursor. Okay, so you have to filter this too. So it's really complicated to work with tailable cursors. Okay. Oh, finally, chain streams. Okay. So you have an idea of what the developers wanted to achieve when chain streams were created, right? So the idea is to allow applications to access real-time data without the complexity and risk that we just saw of tailing the oplog directly. Okay. So internally, behind the hood, what happens is that we are using the aggregation framework. Okay. And internally, MongoDB will the chain stream implementation. When you first start a chain stream, you're gonna create a aggregation framework method, but MongoDB will create some pre-steps, some stages that do all that sort of filtering and security checks that we just saw before. Okay, so that's why they're great to be used. Okay, I'm gonna hurry up. So they can be ran on replica sets and shards. Okay, when you're running, you're executing a chain stream on the primary node. On a replica set, you have to connect to the primary node, and on a sharded environment, you have to connect to the MongoOS. So you can watch to collection, database, and deployment events, which are basically events from all databases and all collections and everything. Okay, so about the global logical clock, there's a lot to talk about this, but the thing is, chain streams use this to keep track of the order of the changes throughout the shards. Okay, I have just mentioned that we can have like more than one operation happening at the same time because it's a sharded environment. They're independent from each other. So what happens is that the chain streams use that to keep a correct order of the events as they're generated. what happens is that that age field that I talked before gets incremented whenever a new operation happens, and this field will this field's value will get spread throughout all the nodes. So everyone kind of knows, oh, another operation happened here, so I should tick the clock, this hybrid clock once more. So that's how we get this order from the events. All right, so we have some examples here. Here we have we're creating a cursor from the donations, okay, on the using the donations collection, okay, and what this function is that whenever you receive a new document on your chain stream, you're gonna just print it out, okay. So that's the event emitter option. So as you can see, we have this change stream on event. What happens is that this is gonna attach a function to each of the cursor, okay? And you can attach how many functions as you want to this cursor, okay? So it's you can do that. Another way, you can use a while loop. Internally, it doesn't really matter which you use. It's just a driver implementation, so you shouldn't care so much about that part, okay? All right, so when you're using chain streams, what you're gonna get is this, right? Like a change event, okay? So I'm gonna go over the main fields here, okay? We have ID, which is gonna have a BSON object. It's not here, but it's gonna have a data field, and the value is gonna be a big hexadecimal value, okay? I'm gonna explain why this field is really important in a few, okay? So we have the operation type, which can be insert, update, delete, okay? We have the full document, okay, that shows up what document was inserted, for instance. So what happens is that not all operations, not all change events are gonna have this field, because, for instance, update operations will not have this field by default, okay? So let's think like this. The oplog does not have the full document information when it receives an update operation. That's because the oplogs, they just care about the delta information that's being generated on each update. So if you deleted only one field, you're not gonna have the full document on the oplog. It doesn't make sense, right? So updates don't have this field by default, okay, but there's a way to mitigate that. I'm gonna explain it in a few, okay. All right. So let's see if there's, okay, yeah, like in an update, you're gonna have this, right? Update description instead of the full document, okay? And then you have other metadata about the operation that is created by, that is inside the oplog.rs collection, okay? All right, so remember that I talked about that big hexadecimal value before? Okay, that's what we call the resume token, okay? The resume token works like this. Internally, the resume token is gonna have like a timestamp, and if your chain stream connection gets interrupted for whatever reason, you can just restart it using the resume token, and it's gonna be like, okay, you're just gonna restart from where you left off without any problem, okay? Sometimes what happens is that you're gonna have your collection being dropped or a database being dropped, and in this case, you cannot resume your chain stream, but you have to start another one. In this case, you can start another one using instead of resume after, it's gonna be start after, okay? And you can put some timestamp, and your chain stream is going to start reading from a specific timestamp where probably the dropped collection happened, for instance, okay? So this is an example. So what happens is that whenever we process a new event, we're going to save the ID field on the resume token, okay? This file, okay? So we have the get resume token. So whenever we restart this piece of code, we're gonna read what's inside here, and we're gonna pass this as a parameter, and then we're gonna restart from where we left off. So in theory, you could run this code like forever, right? If it fails, just restart again, and you're gonna keep track of the last change that you processed, okay? So we can also filter events, all right? So in this case, what happens is that in our pipeline, in our aggregation pipeline, we're using the match operator, and here the operation type is a update, right? So you can think, oh, I'm filtering events. I'm not gonna get everything. What if I need to get everything, right? So should you use that? Yes, you should use that according to MongoDB, because what happens is that one change stream may not keep up with the rate of events as they're being generated, so may lag behind a lot. So what they suggest is that you open several change streams and that you cover all of the documents that you want using the filters. Okay? Does that make sense? All right. Okay, that's what's interesting about the chain stream, right? When we have an update operation and we want to check what is the full document, we can use this option, full document update lookup, okay? What this does is this. So you have an update, but you're using the update lookup operation. So the chain stream is gonna say, okay, I have only the primary key of this record, so I'm gonna search it all over again on the cluster to get that document, okay? So what happens is this. This time where the change stream gets this update operation, gets the primary key, and then does another search on the cluster, what's gonna happen is that this operation is going to take some time, I don't know, half a second, right? What happens if in the middle of the time someone deletes the document you're looking for? You're going to have nothing, okay? It's going to be empty, okay? So you have to take that in account. Documents may be missing if someone deletes a document while before the update operation happened, but after the update operation happened, but before the lookup operation, okay? So you're gonna have a document missing in this case, okay? That's something to look out.
Will it interrupt the operation or will it just carry on?
Sorry, what?
Will it interrupt the operation?
No, it's gonna send a null document and whatever, okay? All right, so production notes. Yes, as I said, full document may return null, okay? We have a 16 megabyte BSON limit, and that's not just for one document, okay? Whenever you're getting like a full batch of a lot of documents, that's gonna, all the documents that your batch is returning need to be less than 16 megabytes, okay? MongoDB cares, takes care of this for you, okay? So events are majority committed by default, okay? So you can rely them on chain streams. There are options for you not to do that if you want to. They're somewhat faster, but not worth it, so worth keeping them on. Oplog size. So when you're using the resume token, you need to take care of the oplog size, because if you don't resume fast enough and you have a lot of operations happening, you're gonna lose the document you're looking for. So you have to plan how big your oplog size is gonna be beforehand, okay? Cold shards are shards that don't get that much interaction on the same collection that you're working for. So when you're on a sharded environment, you have one chain stream that basically fetches documents only from one shard, but it still has to check on all the other shards if there are new documents. And if there are no new documents from the other shards, this operation itself can make your chain streams lower, okay? And of course, you have to take in account that even using chain streams, orphaned documents still can happen. So you have to watch out for that, all right? So, okay, I'll try to explain what we try to do, like, as fast as possible, okay? But the problem that we had with this environment that we had is that they wanted, like, minimal downtime, okay? We could eventually do a dump and restore on a new collection, and all of that old data that we don't need, we could query this data using the query option on MongoDump, and we would just get, like, I don't know, 6 months of data and place it on another collection and call it a day, okay? But the whole operation would take a long time to happen, and they did not, were hoping that, right? So the thing is that our plan was to use this new collection, and we would tell the application team, hey, you can use the new collection when it's ready. Okay, the application would be restarted using the new collection after the migration, and 6 months had to be migrated into the new collection, and after the migration was successful, we would just simply drop the old collection and call it a day, okay? So that was the plan. So we would create, in this case, let's say donations.v2 collection, okay? We would create a v2 collection instead of v1, and it would be sharded and indexed beforehand, before the migration, okay? We would then create a dump file with 6 months of data based on the old collection, okay? And then we would get this dump file, and we would restore this dump file into the new collection, okay? That was our plan. So that's gonna take a long time, right? And while that happens, a lot of data is gonna be incoming, okay? So that's how we wanted to use the chain stream, okay? We would open a chain stream, and while, you know, the whole restore operation happened, whatever happened, like, in the meantime, would be inserted by the chain stream itself, since it's already keeping track of the real data. Does that make sense?
Yeah, let's say the stream is running, you're storing the data, and the change is supposed to happen to the document that was not added yet.
Well, was not added yet.
I mean, like, instead of storing it, so we say we restore 10%,
Yeah,
and that stream, you're getting an update from the stream,
yeah,
which is for
an update, right?
yeah, an update
Oh.
for the data, which is in the somewhere in the remaining 90% of data.
Full document. That's how we use. We will get the full document from using that option, and then we would make a manual upsert, let's say, okay?
So you insert it from the stream, but once it gets to this record from the dump,
Yeah.
it will ignore it because it's going to be an older version, right?
Yeah, okay. In this case, it would ignore. Yeah, the plan would be to ignore only, yeah. So what happens is that the dump file would just say, oh, there's already a document right there. Okay, so I'm going to skip that. Yeah, Mongo restore will skip that, okay, automatically, because primary key violation, right? So we will start this dump into donations v2, okay. We would run some application tests and then redeploy the application using the donations v2 collection. Sounded like a great idea, right? We expected to do that in, I don't know, less than 20 minutes. Yeah, complicated, right? Okay, so what went wrong? So first, what worked? So we know that chain streams are durable, okay? We made sure that they are durable, that all events that happen actually were majority committed. That happened, okay? The resume token indeed ensures the data consistency, so we were able to resume it whenever we wanted. So the chain stream was also able to somewhat handle sharding and replica set failovers without any problem, okay? What didn't work? So the main problem is that full document search will add an overhead on each update. And as I said before, we have a ton of updates. So that's already a cluster that's been suffering a lot. So we would increase the workload somewhat, okay? But also the field document is not completely safe because of the delete operation and things like that. In our case, we saw some empty documents with the full document option. So we would return like a null in our case. So that was not reliable for us. So what happens is that when After the chain stream does its initial optimized query on the TS field that we talked before, it will start reading the chain stream from the end and as the records as they're being generated. So if you do some tweaking on whatever driver you're using, you're gonna see that internally it's gonna be a collection scan, okay? And that's not good, okay? That's not good for the performance, okay? So MongoDB suggests that we open several chain streams whenever we can't keep up with the rate of events while they're being generated. But I've seen a lot of complaint from the community that this adds a lot of overhead to have, like, I don't know, from 5 to 10 chain streams open at the same time is not advisable at all. Your whole cluster is going to feel those collection scans happening at the same time, and your performance is going to be degraded. Any questions so far?
Yeah, actually, continuation of my previous question. So let's say, like, document was not necessarily yet.
Yeah.
It's going to be like the backup is being restored.
Yeah.
Now we have a change stream and we requesting a full document and it gets deleted at that time, which becomes nil. Nothing happens, right? The stream continues, but later on,
You're going to have a whole document.
like an older version of it.
Yeah.
So the delete operation is not replicated.
Yeah.
And if you have more documents on the target than the source,
Yeah.
how do you deal with this one?
Yeah, we at this point we just quit, man. Really, yeah, it didn't work, and that's the whole point. It didn't work for many reasons. So that's one of the reasons as well. So chain streams are, in our case, did not keep up with the amount of events. So we had like I don't know 5,000 operations happening on each shard. Going on one chain stream, so the chain stream lagged a lot, okay? So we decided not to open additional chain streams because the community already complained that, you know, it's gonna hit the performance of the cluster. So yeah, that didn't work as well, okay? Okay, so what happens is like this. When you're using your driver, when you have not a lot of events, but a few events, what happens is that MongoDB has a batch size of 20. So if you're having just a few documents being inserted now and then, your chain stream is not going to react to these events immediately. It's going to wait for you to have, I don't know, 10 or 20 documents, and then the chain stream is going to it's going to receive this whole batch of documents, okay? So if you have an unstable application that's sometimes busy, sometimes not, when it's not busy, you may have this delay, okay? So eventually you could tune this setting to say, okay, I don't want a batch of 20 documents. I want a batch of 1 document. But what happens when things get busy again? You're gonna have like a lot of round trips happening over and over again. So that's very problematic. So it's really hard to tune chain streams, okay? So when you have a lot of events, you have to consider latency and performance. You have to make sure that you can scale, in your case, when you're doing your testing. And to be fair, it's not that the chain streams don't work because the code is bad, okay? It's just that they're trying to deal with a very complicated issue, which is migrating database events with a simplistic solution, okay? So our main note is whenever you hear about messaging in the database, just run away from it, okay? Messaging is one thing, databases are another, and you should not use the chain streams in this sense because, well, not the same purpose, right? Okay, not yet. I just have one additional note. So I said that chain streams are actually being developed, okay? So the full document issue may be fixed soon because in version 6, you're gonna have what we call a pre-image collection. So a pre-image collection is like this. Instead of having only one update operation only on the oplog, what's going to happen when you have a pre-image, whenever you have an update, Before the update, you're going to have a no op operation on the oplog, which already contains the full document. So instead of having to query again for the full document on the cluster, the chain stream, the update operation will have a pointer to the no op operation. And you just can go backwards and read the pre-image from this update operation. Okay? Weird. Okay, that doesn't. Okay, I'll explain it. I'll show some example. Okay. That's a great blog post from. Let's see. No. Where is it? Okay, I'll just share the commit. Oh, where is it? No, I don't have it here. But okay, I can share it with you, the commit. But the idea is to, instead of suffering with this full update operation, that you can have query on your cluster that will return like a null document. You just, on the oplog entry, you have a pointer in the same oplog, like right before the update entry. You're going to have a pointer that to another entry that already has the full document. So you don't have to do a big query on the cluster again, okay?
Where did that full document will come from? Because upload gets truncated, right, at some point. So basically you don't have all the events. But let's say, for example, I installed this document like a year ago and I just deleted it. We would have it in the upload.
Yeah, before the delete operation, MongoDB will get the whole document. It's going to put it back, and yeah, that's how. So, but that's not available. That's going to be available on version 6. Okay, so yeah, chain streams are still under active development, so I'm looking forward to see what's going to happen. But right now, I wouldn't consider using them on a production environment. And that's it. Thank you. Any questions? Oh, I can show you some code if you're interested, but if you want to go. Okay. All right. Show you. So here we have. Okay, I'm just gonna show you the code real quick. So, all right, that's what's happening. In this case, we're inserting, I don't know, 100,000 of documents, and we're waiting 1 second at each operation. Okay? So what you're gonna have is this. So, okay, it's working, and then you can open a chain string. Okay? Okay, that's what you have, like in real time. Okay, so you can check from the operation type if it's update, delete, or something else. Okay, and you can use it, since it's an aggregation framework, and you can filter the events. Okay, and in theory, you could have a higher throughput using multiple chain streams that, I don't know, one is for updates, one is for inserts. And even you don't have to just use the operation type. You can, in this case, you have the, where is it? The full document. You can query like here. Like, I want events only from, I don't know, Camille routine. You can have that as well, right? You can filter directly by whatever field you want. But the thing is that it's still going to be a collection scan, right?
Yeah.
And we hate that in MongoDB.
Unless you have an index on it, right?
What?
Unless you have an index on it?
Yeah, you can have indexes, but it's not going to work because a tailable cursor does not use indexes.
Okay.
Yeah, you just go from top to bottom and just keep listening and issuing get more commands. And that's what they use underneath the hood. It's a tailable cursor, okay? So yeah, performance sucks. I'm having some network issues, but I don't know why, okay? So that was it, guys.